So we're going to continue our work with looking at trig ratios. We're going to use the unit circle and relating trig ratios to the coordinates on the points on the unit circle. We'll determine exact and approximate values for trig ratios. We'll identify measures of angles that generate specific trig values and solve problems using trig ratios. So last class we saw that we have the unit circle, and we just basically looked at the first quadrant of the unit circle as well as north, south, east, west points on the unit circle. And we talked about the fact that you have to be able to count around the unit circle in terms of both degrees and radians. So starting with degrees, we start on the positive x-axis, that's 0 degrees. And then we have 90 degrees. We have 180 degrees. At the bottom, it's 270 degrees. And then back to the start, that's one complete revolution around the circle, or 360 degrees. We can go around these spots in terms of radians. So we have 0 radians. 90 degrees is the same as pi over 2 radians. 180 degrees is the same as pi radians. 270 is the same as 3 pi over 2. And then your complete revolution is 2 pi radians. So we can go around the circle in terms of, basically we've gone around the circle here in terms of every 90 degrees or every pi on 2 radians. But we can also go around the unit circle in terms of every 45 degrees, which is pi over 4 radians. So your first 45 degree angle is there. The next 45 would take you to 90. Another 45 is 135 degrees. Another 45, you're at 180. Another 45, you're at 225 degrees. Then 270, then 315 degrees. And as we said, going around in terms of 45 degrees is also going around in terms of pi on 4 radians. So we've got 1 pi on 4. Another 45 is 90, which is 2 pi on 4s, and that reduces to pi on 2. Another 45 degrees, which is 135, takes us to 3 pi over 4. Another 45 takes us to 180, which is 4 pi over 4 pi. And then 5 pi over 4. Another 45 takes us to 270, which is 6 pi on 4. That reduces to 3 pi on 2. And then we have 7 pi on 4. Another 45, we're at 360, which is 8 pi on 4, or 2 pi. We can also go around the circle in terms of 60 degrees, which is pi over 3 radians. Another 60 would take us to 120 degrees, which is 2 pi over 3. Another 60 takes us to 180, which is 3 pi over 3. That's pi. Another 60 would be 240 degrees. That's 4 pi over 3. Another 60 would be 300 degrees, which is 5 pi over 3s. And another 60 would be 360, which is 6 pi on 3s. That's 2 pi. And finally, we can go around the circle in terms of 30 degrees, which is pi over 6 radians. We got 30, which is 1 pi on 6. 60 is 2 pi on 6s. That becomes pi on 3. 90 is 3 pi on 6s. That becomes pi on 2. Another 30 is 120, which is 4 pi on 6s. That becomes 2 pi on 3. Another 30, though, is 150, which will be 5 pi on 6s. Another 30 takes us to 180, which is 6 pi on 6. Another 30 is 210, which will be 7 pi on 6s. And then we have 8 pi on 6, 9 pi on 6, 10 pi on 6. 330 degrees is 11 pi on 6. So those are all the stops on the unit circle. We saw that because this is the unit circle with a radius of 1, the coordinates at 0 degrees, 0 radians, 360 degrees, or 2 pi radians is 1, 0. You go 1 unit to the right, you don't go up or down. At 90 degrees or pi on 2 radians, it's 0, 1. At pi, it's negative 1, 0. At 3 pi on 2, it's 0, negative 1. And these points tell us the cosine of that angle and the sine of that angle. And if you have trouble remembering the order, it's alphabetical. Then we saw that between 0 and 90 degrees, we could label those coordinates. And we have that hand trick to help us remember. Okay? So you hold it with your palm facing out. The pinky finger is 0 degrees. The thumb is 90 degrees, but it's the other 3 fingers that we use. So if you want 30 degrees or pi on 6 radians, put down that first finger. It's the root of this many fingers over 2, comma, the root of 1, which is 1 over 2. So root 3 over 2, comma, a half. And then at pi on 4, that's the middle finger you're putting down. It's the root of this many fingers over 2 and the root of this many fingers over 2. The root of 2 over 2, comma, the root of 2 over 2. And then at pi on 3, put down the second last finger, the one next to the thumb. It's the root of this many fingers over 2, comma, the root of 3 over 2. Root of 1, which is 1 over 2, root of 3 over 2. So if we want, we can fill in the remaining coordinates on the unit circle. Pi on 6 and 5 pi on 6 are related because they have the same reference angle. A reference angle of pi on 6. The reference angle is the angle between the terminal arm and the x-axis. So we can say that those angles are pi on 6 radians or 30 degrees. So they are connected. And what that means is that you're going to have the same 2 numbers for the coordinates. The only thing that might change is whether they're positive or negative. And to get in the second quadrant, you have to go left from the origin. So the x value is negative. This will be negative root 3 over 2. But you're still going upwards from the origin, so the y value is positive. Same 2 numbers as from the first quadrant, with the same reference angle, or another way of looking at it, the same denominator of 6. The only thing that changes would be the sign. So the ones that have the same denominator of 4, that has a reference angle of pi on 4 radians, as does this one right here, a reference angle of pi on 4 radians. So the numbers, the coordinates will be the same, except there's a change in the sign for the x value because you're going left from the origin. But your y value remains the same because you're going upwards. And for 60 degrees, or pi on 3 radians, it'll correspond to 120 degrees, or 2 pi on 3 radians. They have the same denominator. They have the same reference angle of pi on 3 or 60 degrees. So the coordinates will be the same numbers. It's just that the x value is negative in that quadrant. So the same thing will work for down in quadrant 3. Here they're both negative because you're going to go left and down from the origin. But the 7 pi on 6 will correspond to the numbers for pi on 6. They have the same reference angle. All that changes are the signs. So it'll be negative root 3 over 2, comma, negative a half, negative root 2 over 2, comma, negative root 2 over 2, and negative a half, comma, negative root 3 over 2. And in the fourth quadrant, the same thing will happen, only now the x will be positive, but the y will be negative. But 11 pi on 6 will correspond to pi on 6. They have the same reference angle. All that changes are the signs. So this will be positive root 3 over 2, comma, negative a half, positive root 2 over 2, comma, negative root 2 over 2, and positive a half, comma, negative root 3 over 2. And finally, as we saw last class, we can get the tan of theta from the reference, or from the unit circle. I remember that tan of theta is equal to sine theta over cos theta. So at pi on 6, if we want the tangent of pi on 6, it'll be the sine, which is 1/2, divided by the cos, which is root 3 over 2. And to divide by a fraction, we multiply by the reciprocal. The 2's cancel. You'll get 1 over root 3, which if rationalized will be root 3 over 3. At 45 degrees, when you divide sine by cos, because the values of sine and cos are the same, they're both root 2 over 2, when you divide something by itself, you'll get 1. The tan of 45 is 1. And at pi on 3 radians, or 60 degrees, if you do sine divided by cos, it's root 3 over 2 divided by a half, or root 3 over 2 times 2 over 1, which is root 3. And for the other stops, again, we go back to our reference angles. At 5 pi on 6, which has a reference angle of pi on 6, the value of the tangent will also be root 3 over 3, but in this case it'll be negative because you're dividing positive a half by negative root 3 over 2. And at 3 pi on 4, that has the same reference angle as pi on 4. So it's also going to be, or involve the number 1. However, because you're dividing a positive by a negative, it's negative 1. And so for the same reason, the tangent of 2 pi on 3 would be negative root 3. So down at 7 pi on 6, that'll correspond to 5 pi on 6. But in this case, because you're dividing a negative by a negative, it's positive root 3 over 3. And positive 1. And positive root 3. But in the fourth quadrant, tangent is negative. Negative root 3 over 3, negative 1, and negative root 3. And then at multiples of 90 degrees, when you divide sine by cos, 0 divided by 1 is 0. The tangent of 0 is 0. But at pi on 2 or 90 degrees, you're going 1 divided by 0, which doesn't exist. It's undefined. At pi, 0 divided by negative 1 is 0. At 3 pi on 2, again, you're dividing negative 1 by 0, which doesn't exist. So it's undefined. So there's the entire unit circle. And on the next page, there's a hard copy of it for you to refer back to. The tangent values aren't written in there, so if you want to use that, you'd have to write those in. But as we said, we only really need the first quadrant. Okay? So that's all you really need, but going forward for an assignment, you can look back at these pages and use them. But on a quiz or a test, this is not given to you. So you have to be able to work with the unit circle from memory. So it's best just to use the first quadrant and then what we've talked about, reference angles. Also, if we go back, and actually we can do it on this one or on the previous one, this also verifies our CAST rule. Remember, the CAST rule tells you which ratios are positive in which quadrants. The first quadrant is A. They're all positive. Sine, cosine, tan are all positive. The second quadrant is the S quadrant. Sine is positive, but cosine, tan are negative. In the third quadrant, that's the T quadrant. Tangent is positive, but sine and cos are both negative. And in the fourth quadrant, that's the C quadrant because the cosine is positive, but the others are negative. Okay. So, last class, we worked with the unit circle, filled in all the values along with all the coordinates, discovered that the coordinates are related to the sine, cosine, tangent of the associated angles. Because tangent is sine over cos, the y over the x. So the sine, cosine, tangent are known as primary trigonometric ratios, but there are also three reciprocal trig ratios. The cosecant is the reciprocal of sine. The abbreviation is CSC, and if you have a point x comma y on the unit circle, because the cosecant is the reciprocal of sine, it's 1 over the y value. If the sine is negative root 3 over 2, then the cosecant would be the reciprocal, negative 2 over root 3, which could be rationalized. The secant is the reciprocal of the cosine. The abbreviation is SEC, because on the unit circle, the x value gives you the cosine, then 1 over the x value will give you the secant. If the cosine is a half, then the secant is 2 over 1 or 2. And the reciprocal of tangent is the cotangent. The abbreviation is COT, and because tangent is y over x, sine over cos, then the cotan will be the reciprocal, x over y. And we've seen on the circle that we just looked at, if the tangent of theta is 0, which is 0 over 1, then the cotan is undefined because it's 1 over 0. So if we look back at the unit circle, okay, at 90 degrees, the tangent is undefined because it's 1 over 0. But the cotan will not be undefined. It'll be 0 because it's x over y, 0 divided by 1. Okay, at pi radians, the tan is 0 because it's 0 over negative 1. But the cotan is undefined because it's negative 1 over 0. Undefined. And at 270, the tangent is undefined because it's negative 1 over 0. However, the cotan will be 0 over negative 1, which is 0. Okay? So the one way to remember what primary ratio goes with what reciprocal ratio, the sine and the cosecant go together. Let's do it this way. Sine equals 1 over the cosecant, or you could say that the cosecant is 1 over sine. The cosine is 1 over the secant, or you could say the secant is 1 over cos. And the tangent is 1 over the cotan, or you could say the cotan is 1 over tan. So these ratios go in pairs. Sine goes with cosecant, cosine goes with secant, tan goes with cotan. Each of those pairs has only one word co in it, co. So that would be something that you might use if you're having trouble remembering which one goes with which. Sine and cosecant, only cosecant has co in it. Cosine goes with secant, only cosine has co in it. Cotan and tan, I think, are pretty easy to remember. Yes? Nope. You have to go 1 over. Assign to the negative 1 button, and we'll use that in this class, but that's if you're told that the sine of an angle equals, say, a half, and you want to find the angle, you work backwards by going second function sine of a half. It tells you what the angle is. The angle so that the sine of that angle equals a half. And you can try it on the calculator. Let's just see what mode I'm in. I'm in degrees, okay. So if I go second function sine of 0.5, or a half, the angle's 30 degrees. On the unit circle at 30 degrees, the sine is a half. When you go second function sine of a half, you're asking the sine of what angle equals a half? And the answer is 30 degrees. Okay? Also remember that sine is opposite over hypotenuse. That's from SOHCAHTOA. So the cosecant will be hypotenuse over opposite. From SOHCAHTOA, the cosine is adjacent over hypotenuse. So the secant is hypotenuse over adjacent. And SOHCAHTOA tells us that the tan of theta is opposite over adjacent. So the cotan is adjacent over opposite. So again, as we wrote above, how are the coordinates of the points on the unit circle related to the reciprocal trig ratios? We know that sine is the y value, so the cosecant will be 1 over the y value. We know that the cosine is the x value, so the secant will be 1 over the x value. And we know that the tangent is sine over cos, so it's y over x. Therefore, the cotan will be the reciprocal, x over y. So, like we did last class, we can find the exact value of each of the following. So that tells us that they're on the unit circle somewhere. The only difference now is that we're going to have some reciprocal ratios in here as well. And we'll do them the same way we did them last class. We'll figure out which quadrant our terminal arm lies in. That'll tell us whether the answer is positive or negative. And then we'll use the values from the first quadrant and a reference angle to get our answer. And like I showed you guys last class, we can always use our calculator to check our answer. Make sure that it's correct. So let's start here. By drawing the first quadrant of the unit circle. At 30 degrees, the coordinates are root 3 over 2, comma, a half. At 45 degrees, they're both root 2 over 2. And at 60 degrees, it's 1/2, comma, root 3 over 2. The cosine of 5 pi on 6. So it's going to correspond to the angle in the first quadrant with the same denominator of 6, which is pi on 6, which is our first stop. The cosine is the x value, which is root 3 over 2. However, in this case, it's going to be negative root 3 over 2 because 5 pi on 6 is 1 pi on 6 short of 6 pi on 6, which is pi. 6 pi on 6 would be pi. 5 is 1 short of that. So it's in the second quadrant, and according to our CAS rule, that's our S quadrant. So only sine is positive, so therefore cosine is negative. That would be the answer. And you can check it on your calculator. we have to be in radian mode. If you take the cosine of 5 pi on 6, you can put it in there just like it's written. Cosine of 5 pi on 6, it gives you that decimal. Well, if you go negative root 3 divided by 2, get exactly the same decimal. That just shows that the answer that we wrote down as an exact value is the correct answer. Calculator gives it to us as a decimal, an irrational number. We want the exact value, so we use the unit circle, and we can still use our calculator to check. All right, the next one is a sine of negative 4 pi on 3. Well, if we look at the first quadrant with a reference angle of pi on 3, the sine, which is the y value, is root 3 over 2. However, we need to make sure that it's whether it's positive or negative. So where is 4 pi on 3 on the circle? Well, 4 pi on negative, I should say 4 pi on 3 means you're going clockwise 4 pi on 3. So 3 pi on 3 would be halfway around the circle. We need to go one more pi on 3 past that, which will be once again in quadrant 2. But in this case, we went in a negative direction, which is a clockwise direction. 3 pi on 3 would be pi, halfway around. We need to go one more pi on 3 past that, which again puts us in the second quadrant where the sign is positive. The CAST rule tells us that. So the answer is positive root 3 on 2. And again, if we check that in our calculator, the sine of negative 4 pi over 3 is 0.8660. And if you do the positive root of 3 over 2, that's what you'll get. This shows that our answer is correct. This next one, the secant of 315 degrees. Well, 315 degrees is halfway between 270 and 360. It has a reference angle of 45 degrees, which is the same as pi on 4 radians in the first quadrant. The secant is the reciprocal of the cosine. The cosine is positive root 2 over 2. But remember that originally came from 1 over root 2, and then we rationalized it. So if you say the cosine is 1 over root 2, then the secant would be root 2 over 1, or root 2. And the CAST rule tells us this is the cosine, so therefore the answer is positive root 2, because the secant corresponds to the cosine. If the cosine is positive, the secant would be as well. Now, if you're going to check this in the calculator, you'd have to change the mode into degrees. And we don't have a secant button on our calculator, so we'll have to go 1 divided by the cosine of 315, which is that decimal, and if you go the root of 2, get the same decimal. So it checks. The cotan of 270, well, that's on our unit circle, 270. It's right there. And down there, the coordinates are 0, negative 1. The tangent is sine over cos, which is negative 1 over 0. That's undefined, but the cotan would be cos over sine, 0 over negative 1, which is 0. And to check that on our calculator, this actually isn't going to work, I don't think, because if you go 1 divided by the tan of 270 degrees, yeah, it gives you an error because the tan of 270 doesn't exist. So you can't check this one on your calculator. The tangent of pi on 2, well, again, pi on 2 is on our unit circle right there, where the coordinates are 0, 1. And tangent is sine over cos, 1 over 0, which again is undefined. This one we can check on our calculator. We just have to change it into radian mode. If you take the tangent of pi on 2, it doesn't exist. The cosecant of 7 pi on 3. So where's that on the circle? Well, it's a positive angle. And if we do one trip around the circle, that is 6 pi on 3s. 6 pi on 3 is the same as 2 pi. One trip. We have to go one more pi on 3 past that. Okay, Sant? What quadrant does that put us in? And the reference angle is pi on 3. So if we go up to pi on 3 radians, and remember that the cosecant is a reciprocal of sine, the sine is root 3 over 2, so the cosecant will be 2 over root 3. Whoops. Which, if we rationalize that, which you always should do, we get 2 root 3 over 3. So to check that, our calculator is in radian mode. Again, we don't have a cosecant button. We have to go 1 divided by the sine of 7 pi on 3. Which is that decimal. And if you go 2 root 3 divided by 3, you get the same decimal. So that shows us that our answer is correct. Try those last 3 on your own. Nope. This is water with Crystal Light and emergency pack. I think you owe me about 4 pops, don't you? Huh? I don't know about that. All 0 of them? So negative 7 pi on 6 means you're going in a clockwise direction. 7 pi on 6s. So halfway around would be 6 pi on 6s. We have to go one more pi on 6 past that. So secant is reciprocal of cosine. The cosine of 7 pi on 6, negative, will be related to the cosine of pi on 6 in the first quadrant, which is root 3 over 2. But because we want the secant, it'll be the reciprocal 2 over root 3. And also the cast rule tells us that this is the S quadrant, so sine is positive, cosine and secant will be negative 2 over root 3. Or negative 2 root 3 over 3 if you rationalize. So we already have that decimal in our calculator, only it's going to be negative. If we take 1 divided by the cosine of negative 7 pi on 6, we get that same decimal, only it's negative, which we know it needed to be. cosecant of positive 5 pi on 4. So that means we're going around the circle in a counterclockwise direction. Halfway around would be 4 pi on 4s. One more pi on 4 takes us to 5 pi on 4. Our cast rule tells us that this is the T quadrant. So only tan and cotan will be positive, cosecant will be negative. And it'll correspond to whatever we get for the sine of pi on 4 in the first quadrant, which we had written as root 2 over 2. But remember, that came from 1 over root 2, which we're going to use because we want the cosecant, which will be the reciprocal. And the reciprocal of 1 over root 2 will be root 2 over 1. We already saw that the root of 2 is 1.4. We had it above there. So when we do the cosecant, which is 1 divided by the sine of 5 pi on 4, we get the negative decimal. Right? If you take negative root 2, same decimal. The last one, the secant of 11 pi on 3. So that's a positive angle. Sant, how many pi on 3s have we gone around with one revolution? How many pi on 3s? Yeah. You better pop on that. It'll be 6. How about another one? Yep, which would take us to... Do it in your head. 6 plus 6, carry the 7, 12 pi over 3. Yeah. Do we have to go any more? No. That's right. So we're going to back up 1 pi on 3. Approximately right there. So we can erase this bit there. Our cast rule tells us this is the C quadrant. So cosine is positive, which means the secant will be positive. And our reference angle is pi on 3, same denominator of 3. And if we go to pi on 3, the cosine is a half. So the secant will be the reciprocal of that, 2 over 1, which is 2. And if we do that on our calculator, we'll get that answer by going 1 divided by the cosine of 11 pi on 3. We get that answer. So we can check it. Okay? And if you're using an angle that's not on the unit circle, you can do it on your calculator, but you have to round it. In this case here, it says round our answers to 4 decimal places. The cotan of 7 pi on 5, well, that'll be 1 divided by the tan of 7 pi on 5. Which is 0.3249 to 4 decimal places. Let's skip B because we have to change to degrees for that one and go to C. And because there's no degree symbol, that means it's radians. So it'll be 1 divided by the sine of 4.2 radians. Not all angles in radians are as a multiple of pi. Remember, whenever you're not given a unit, when there's no degree symbol there, it means radians. So negative 1.1473. But for B, we'll have to change our mode to degrees. And the secant is reciprocal of cosine, so 1 divided by the cosine of 260 degrees. Negative 5.7588. Okay? So Thursday is a day to rewrite your Unit 1 exam. So that means hopefully you can come here at the start of lunch to start it. And then if you need more time in Block 4 to finish it. If not, you have to get it all done in Block 4, which means you missed the lesson. But it'll be recorded so you can watch it after. Okay? And you have to have that review assignment complete before you can do the rewrite. Show your work. Yeah. No. No. Not the same test.